Okay, we're going to be looking at writing function rules to solve problems, or I might write an equation. So what we're going to be looking for in these story problems or word problems is what's going to be the constant change. That's going to replace our a value in our y equals ax plus b. And then b might be 0, or it might be something that is a one-time deal, or an additional cost that only appears once. Okay, so Tom takes a job that pays him $17 an hour and gives him a one-time $2,000 signing bonus. Write an equation to express the amount of money Tom makes for the number of hours he works. Okay, so hours he works is going to be X, money made is going to be Y. So you've got Y equals, now it would be AX plus B. And what we'll notice here is that the $17 an hour, so X is going to be the number of hours. So for every hour he works, you get $17. That's going to be that constant change. So we're going to replace that with Y, or replace A with 17. So you get $17 per hour. Okay, then the next one is what is anything that is a one-time fee. And we'll see that that's a right here, $2,000 one-time signing bonus. So then we add that, that becomes our B. So now we have our equation, Y equals 17X plus 2,000. Okay, so now that we have that equation, we can answer this next part. How much money does Tom make working 70 hours? So we just take our equation, and what we're plugging in is 70 for our X. X refers to hours, so we're just going to replace that X with 70 hours to find out how much he makes in 70 hours. So that's going to give us our Y, which is our total value, our total money, and this was our hours. So 17 times 70 is going to give us 1,190. And then we're going to add 2,000 to that. So when you add those two together, you get Y equals $3,190. And so that's what we're going to be doing. This is going to be maybe a little more straightforward. This next one we're going to do is going to get you to kind of think, how would you set that up from their description that they say. Okay. So now Neptune has 8 known moons. This is 2 more than a third of the number of known moons of Saturn. How many moons is Saturn known to have? Okay, so we know that 8 is equal to 2 times, or 2 more. 2 more would be plus. Okay, so it's 2 more, which is plus a third of the number of Saturn's moons. So Saturn's moon, the number of Saturn's moon is S. So we know that 8 is 2 more than a third of Saturn's moons. So that'd be 1/3 S plus 2. Okay, so there we've set up our equation. So this Neptune has 8 known moons, and we're setting that equal to, because it says 8 known moons, this is equal, or this is 2 more. This refers to equals, and then 2 more than a third of the number of known moons of Saturn. So that's going to be a third of the known moons of Saturn plus 2. That would be that 2 more is going to be a plus 2. So now we've got our equation set up, and now this is a 2-step equation that we're going to solve for S. First step in 2-step equation, we get rid of the constant. So we get rid of the constant by adding its additive inverse. So in this case, plus 2, the additive inverse is minus 2. So we're left with 6 equals 1/3 S. And now our last step to solve for S and get S by itself is we have to divide by the number in front of S. But when you divide by a fraction, it's the same as multiplying by its reciprocal. The reciprocal is just this fraction flipped. So this would become 6 times 3 over 1 is equal to 1/3 times 3 over 1 times s. Okay, so these are going to cancel out, leaving us with just 1. So 3 times 1 is 3, 3 times 1 is 3. 3 divided by 3 just gives us 1s, which is the same as s. So these cancel out to be 1. And now we've got 6 times 3, which is equal to 18. And 18 divided by 1 is just 18. So here we have solved. Saturn has 18 known moons. And if you plug in 18 into our original equation, 1/3 of 18 is 6. 6 plus 2 would equal 8. Okay, last one. Now we're given a formula, or we're given a function rule here. And so it says Fahrenheit and Celsius temperatures are related by the formula F equals 9/5 C plus 32. This would be F stands for Fahrenheit, C stands for Celsius. Okay, what is the Celsius temperature if the temperature is 77 degrees Fahrenheit? Okay, so now we're going to have to rewrite this function and solve for C. So we know that it's 77 degrees Fahrenheit is equal to 9/5 C plus 32. So two-step equation once again. Our first step is to get rid of the constant. We minus 32 to both sides. What you do to one side, you have to do to the other. So then that's going to give us 55 is equal to 9/5 C. Once again, we have to divide by 9/5 or multiply by the reciprocal. So we're going to write this as 55. And we can write 55 over 100 is the same thing as 55 times the reciprocal, which is 5/9, is going to be equal to 9/5 times 5/9 C. Once again, these are going to cross out, leaving us with just C. And then same thing is going to be 55 times 5/9. So we check and see if there's any cross multiplication we can do. Doesn't look that way. So we just take 55 times 5, which is going to be 275 divided by 9. Okay, and then to find out what that total equals, we just divide that by 9, and we get, I'm just going to round it, 30.6 degrees in Celsius. Okay, so there we have our degrees Celsius. Another thing we can do if we want to find what the function rule for C would be. And so if you got F equals 9/5 C plus 32, we're going to do the same steps. You minus 32 first. So that's going to become F minus 32 is equal to, I'm going to move this down just a little bit. Is equal to 9/5 C. And then you're going to multiply both sides by the reciprocal. So this will give us our function rule to go for when we're given Fahrenheit to transform it into Celsius. So these are going to cancel out, So we're just going to be left with 5/9 times F minus 32 is equal to C. So now here for the second one, we're just going to plug in 22 for F here. So 22 minus 32, and sorry, that's a negative 22. And now we can just go negative 32 minus negative 22 minus 32 is going to give us a negative 55. And sorry, that's negative 54, not 55. Okay, and then when we take 5/9 of 54, negative 54, we're going to get C. And so our answer is going to be a negative number. And it should be close to that 30. And actually it is in fact exactly negative 30. So there we've rewritten that function. So if you're going to be continually doing conversions from Celsius from Fahrenheit, you'd want to rewrite this equation so that it's easy to just put something in instead of going through each step each time. What you'll notice though is all these steps are pretty much what you're doing here. It's just an easier format to rewrite this first to convert from Fahrenheit to Celsius.